Hi, I'm Claire Russell of Target Maths. If you're new to my channel, then I create lots and lots of resources to help you prepare for your GCSE maths exam. This particular video is for those of you studying and preparing for the November Resit. What I've done is gone through all the past Resit papers to look for the most common topics that are coming up. So in this video, we have got 15 non-calculator questions. So this is to support paper 1. It ranges from grade 3 to grade 5. So we're in the more challenging end of the paper. And what I'd suggest that you do is just download the document in the description. That way you can give the questions a good go and then come back to the video and watch for the solutions. Alternatively, you can just quickly hit pause when the questions come up on the screen, have a go, and then play for the solution. So once you've done this, it's going to help you identify your strengths and your target areas. Now, I have a lot of quick one-a-day revision questions, and they're all into playlists. So if you do see a specific area that you want to target, do check those playlists out because you might see more exam questions to have a go at there. I've also included, where possible in the description, links to more in-depth explanations to methods. So if there's a particular topic that you're uncomfortable with, you need like a bit more information on how you approach them, then those could be incredibly useful to you as well. If you found the video and the resource useful, then please do subscribe. I'm currently working on the calculator resource that will drop hopefully in the next few days. And good luck with using this resource. Good luck with your November exams. And I hope I'm able to be a good support whilst you're studying and preparing. Okay, so our first question is a two-way table. We're just going to fill in as we go the information that we're being given. So 11 of the 20 females said swimming. So we fill in our 11. 2 males said tennis and 5 students said cricket. So 5 in total. If I look at this table, there is one more cell that I can complete. I have 2 pieces of information here, which means I can work out that that missing value is 10. 10 and 20 make that total of 30. The next line is telling me that the number of male students who said cricket was the same. So the same value is the number of male students who said swimming. So I've got 10 male students, 2 of which like tennis. So I've got 8 males left over. I'm going to share those, divide it by 2 into cricket and swimming, and it completes those cells nice and quickly for me. There isn't any more additional information. It's just complete the two-way table. So I should have enough now to be able to just go around and finish this off. So I can see here I've got a missing cell. 2 pieces of information with a missing 1 means that I would be able to work that out. This is the total, and 4 plus 1 will make that total. I've got 4 and 11 that will total to 15. And then I can work along. I've just got that 1 cell missing. 11 and 1 is 12. I need it to add to 20. So we're putting 8 in there, and 8 and 2 is 10. And we have done the first question. Okay, question number 2. Jamil makes a drink by mixing 1 part of orange squash with 9 parts of water. So let's get that sentence into a ratio. Let's code it up as quickly as possible. So we've got squash to water, 1 to 9. And we're being told that he uses 750 milliliters of squash. So we'll put that 750 in the squash column. Now I have enough information to work out the amount of water that would be needed. I would multiply the squash 1 by 750 to get 750. So I have to multiply my 9 by 750. So let's set up a grid. Now, how you do this is how you do it. You do not have to be doing it this way. I quite like this method. It's quick and easy. So 9 zeros are 0, 9 fives are 45, 7 nines are 63. And then add through the diagonals, I've got 0, 5, 7, and 6. So nice and quickly, I've worked out that the water is 6,750. Jamil is going to put the drink he has mixed into litre bottles, and we've got to work out the greatest number of bottles. So I know how much squash and how much water is going in to make the drink. So we need the total. So the total fluid is the water plus the squash, which is 7,500. Now, we're in millilitres at the moment. We need to divide through by 1,000 to get it into litres, which would be 7.5. And it's the greatest number, and the greatest number is 7. And we would pop that on our dotted line. Okay, question 3 was a 4-mark question. We've got 3 kilograms of carrots costing £1.80, 2 kilograms of carrots and 5 kilograms of potatoes. We've got a cost for that. And then we've got to work out another scenario of our carrots and potatoes. Now, in order for us to work out the carrots, we can use that first line. If 3 kilograms cost £1.80, I can divide through by the 3. 3's into 1 don't go. Put the point in, carry the 1. 3's into 18 goes 6. So we've got 60p. I've got to work out the cost of 4 carrots. So I'm going to take my 60p, times it by 4, and I have got 6 4s are 24, add the 0 into pounds. I've got £2.40 for my 4 kilograms of carrots. And it's not a bad shout to do that little bit of labeling, because we're going to go away, do some other maths, and then we might lose where we are. We might get a little bit muddled, and we need to be really clear what we've got. So a bit of labeling along the way, I think, is quite good. Now, the second line says we've got 2 kilograms of carrots. So 2 kilograms is going to be 60 pence times 2, which is 120 or £1.20. And we're going to take that away from the total. When we take that away from the total, it's going to give us what the potatoes cost. Okay, so 5 take 0 is 5, 4 take 2 is 2, and 3 take 1 is 2. So there are 5 kilograms of potatoes that cost £2.25. So we're going to take our £2.25 and divide it by 5. And that'll get us the cost of 1 kilogram. So we've got 0, put the point, carry the 2. 5's into 22 go 4, remainder 2, and 5's into 25 go 5. So 45 pence for 1 kilogram. We've got to work out 2 kilograms of potatoes. So we just need to times that through by 2, which is 90p. And then we've got the last step. £2.40 for our carrots, 90 pence for our potato, giving us £3.30 to go on the dotted line. Question 4. The first part of this question is asking us to explain why Jasper cannot be correct in his claim that x could be 0.5. It's a 1 marker, so it shouldn't be overly complicated. What we actually need to do is take what he believes it could be and put it into the expression here. So we're going to do 4 times 0.5 take away 2. 4 times 0.5 is 2. 2 take 2 is 0. It mathematically cannot be 0.5 because you cannot have a 0 length. So words to that effect are going to get you that mark. Okay. So the second part is telling us that the kite has a perimeter of 64 centimeters. So I know its numerical value. It's also telling us that AD, which is here in my kite, is 3AB. So let's take that information, get it on, make it really clear, and then consider what AB is. AB is this length of my kite, which means it's this expression, 4x minus 2. So I'm going to be doing 3 times 4x minus 2. Remember, anything squashed means times. When I expand that, I get 12x minus 6 for the edge AD. Now, this is a kite. Kite is symmetrical. So this edge here is equal to this edge, and this edge here is equal to this edge. So if I want to know what the perimeter is in algebra, I'm going to add up 4x minus 2 twice and 12x minus 6 twice. That's all the edges. If I add my x's, I get 32 x's. If I do the negative, minus 2 is minus 4, etc. Or just add all the numbers, you'll get 16, and it will be minus 16. So this expression that we've now created is representing the perimeter. We've added all the edges. We have been told that the perimeter is equal to 64. So the algebra equals the number. And now we're just solving equations. If I want to know what x equals, I will get it on its own. So I'm going to move the negative 16, land is positive 16, and I've got 32x equaling 80. And then I need to divide through by 32. Now, this is a non-calculator paper. It doesn't say that you have to give your answer in its simplest form. X is 80 over 32. However, if you want to simplify it through, you can literally just half. Divide by 2 is 40 over 16. Dividing by 2 again would give us 20 over 8. We could divide by 2 again to give us 10 over 4, and then again to give us 5 over 2. That's the same fraction simplified. And as a decimal, it would be 2.5. But remember, they are asking you to find the value of x, which we did at this point here. Okay, question 5 is a fraction question. It's divide, which means it is keep, change, flip. So we've got 3/5, change the divide to times, flip, and we end up with 18 over 5. Once you've turned it into a multiplication, you just do it. Now we've got to give our answer as a mixed number. So how many 5s can we get into 18? We can get 3 with 3 left over. So a nice, straightforward fraction question there. Okay, our next question, question 6, is multiplication and a division. So again, when it comes to the multiplication, you will use whichever method you find best for yourself. I'm demonstrating this one because this is the one that's easier than the traditional method, and a lot of people do use it. So we're ignoring the decimals. We've set everything up. We're now going to multiply in. So we've got 0, 6, 12, 12, and 24. And then you add through your diagonals. 6, 4, and 1 is 11. So you just carry that 1. You've got 5, and you've got 1. So we've got 1, 5, 1, 2 as our digits for 63 times 24. Now we need to think about the actual decimals here. 63 has been divided by 10 to make 6.3. So we're going to go in one place to allow for that. And then 2.4 has done the same thing. 24 would be divided by 10 to get that in. So you move it in another place, and your answer is 15.12. Another way of thinking about it is just count it out. I need to move it out once to get it out of 63. So in once. I have to move it out once. So I moved in again 1. Okay, when it comes to division, first thing is if you have been given a decimal to divide by, we are going to have to manipulate the question. We don't want to be dividing by decimals. No one wants to do their 1.6 times table. So if we times everything by 10, so this would become 598.4, and this would become 16. We've written an equivalent question. So we won't have to change it back down at the end. The result will be correct. So now we've got to divide into our bus shelter by 16. Now I don't know my 16 times table, so I would be spending a little bit of time writing them out until I was happy that I had a few to get me going. I don't know how many I'm going to need to write, so just get started and then we can always add to it if we need to. So 16s into 5 don't go. Carry the 5 and you've got 59. 16s into 59, I'll check my table. That's too big, so I've got 3, and then I have to work out the difference so that I can find out what to carry over. It's 11. So I've now got 118, and obviously I'm going to need to write a few more. So the next one is 96. The next one is 112. I know if I add on again, it's going to be bigger than the 118 I need. So I'm not going to do any more unless, again, I have to. So 1, 2, 3, 4, 5, 6. I've got 7 now. So pop up the 7. And the difference is 6. So that's what I'm carrying over. You can see at this stage, I've hit the decimal. So I'm going to put that decimal up and then work on the 64, which goes exactly 4. So my answer is 37.4. Right, question 7. Robin buys a watch for 80. He sells the watch for 56, and we have to work out his percentage loss. Percentages. If we have to write an answer as a percentage, it will start its life first as a fraction. So we will be setting up a fraction, which we will then turn into a percentage. So he's bought the watch for 80 and he sells it for 56, and it's all about the loss. So the first thing that I'm going to do is work out that loss. So 80, take away 56. 0 take 6 I can't do, so I'm going to have to take 1 from the next column. 10 take 6 is 4, 7 take 5 is 2. So I have £24 that he's lost. And I put that over the original. And then this gets multiplied through by 100. Now I'm going to times by the top and divide by the bottom. I'm going to times first because that's going to be easier to do. And then you can start to see 24 is in the 8 times table. I can cancel these zeros. 8s into 24 go 3. And then I've still got that 0. 30% is the answer. Now, these questions can be percentage profit, they can be loss, percentage change, and they all work in exactly the same way, which is you work out the difference, put it over the original, there's the fraction you need, and then times through by 100. So that's a really good formula to be aware of. Okay, our next question is to write 156 as a product of prime factors. So we take the 156 and we just start looking for factors that multiply to make it. Now, the easiest thing to do when you've got a large even number is to half it. But halving 156 isn't necessarily easy for everybody. So you have to have faith in your bus shelter. We're going to divide by 2. 2s into 1 don't go, carry the 1. 2s into 15 go 7, remainder 1. And 2s into 16 go 8. So I've got 78. And then I'm going to repeat the process. It's quite large. I'll just half it. I'll just divide by 2. If 78's tricky, you will do it this way. 2's into 7 will go 3, remainder 1, and 2's into 18 go 9. So I've got 39. Now that's an odd number. I won't be able to half that. So I will start to consider whether it's in the 3's. It is in the 3's. We can just show it, just so you see it. 3's into 3 go 1, 3's into 9 go 3. So it's 3, and 13 is a prime as well. So those are all my prime numbers. I have to write it as a product. Product means times. So we finish it off with 2 times 2 times 3 times 13. Or you could write it like this, and that's absolutely fine as well. Okay. Now, the second part of this question is using that 156 and then another number and asking for the highest common factor. Now, we already know the prime factors for 156. It's 2, 2, 3, and 13. What we now need is to work out what it is for 130. So we've got 13 and 10, 2 and 5. And then we're going to pop all the information into a Venn. So this circle is my 156 circle, where I've got 2, 2, 3, and 13. This is my 130, where I've got 2, 5, and 13. And then I just match up whatever I can to go into the middle. So a 2 can match, and a 13 can match. 2 and 3 would live here, 5 would live here. Now, the highest common factor is the middle section only. So it's 2 times 13, which is 26. If you were being asked for the lowest common multiple would be everything inside. So it just depends on the type of question that they ask, really, as to what part of the Venn diagram you use. Okay, question 9. The first line is telling us that all the even numbers less than 19 are going to be in this diagram. Now, top tip, write them out. 2, 4, 6, 8, 10, 12, 14, 16, 18. That way you can see the numbers that you need to have in this diagram. You've been told what should be in the A circle and the B circle, and then you've got to complete. So anything that's matching will go in the middle. So we've got 6 and 6, got 18 and 18, but also cross it off on the main list. Those numbers are now in the diagram. A also has 12, so cross it off the main list as well. And then you've got 2 and 14, 2 and 14. And by having this main list, it's really easy to see what's not in a circle. So we list that on the outside. So we've got 4, 8, 10, and 16 in the rectangle. So it's in the diagram, but not in the circles. All right, we have another question on fractions. Really, really important fractions. So common. This is a mixed number question, and we have to give our answer as a mixed number as well. We're going to use fraction methods, but we've been given mixed numbers. So it's really important that we change our mixed numbers into fractions so we can use our fraction method. To do this, we take the denominator, times it to the whole number, and then we add in the top. So we have got 5 times 4 is 20, plus 1 is 21. So we've got 21 fifths, 21 over 5. Do the same. 3 2s are 6, plus 2 is 8. So we've got 8 thirds, 8 over 3, and it's a takeaway question. I think this is just the best method for adding and subtracting fractions. It is our smashed window. It takes so much of the thinking out of the problem. You just set up the first fraction, and then the second goes down the side, and you multiply in. So we've got 40, 15, and 63. This number here is always the denominator. And then these numbers we either take away or we add, depending on the question. Our question is a takeaway. So that just needs tidying up. So 63 take away 40 is 23 over 15. And then remember, we have to do that mixed number as our answer. So 15s into 23 go 1. There's 8 left over the 15. And that would be our final answer for question 10. Okay, question 11 is a ratio question. Now, remember, it's always a really good idea to get any ratio sentence, which is what we have here, into its ratio kind of code. We work in codes and symbols and numbers. We don't work in sentences. So if we can get rid of them, we will. So we've got Rosie to Matilda to Ibrahim, 4.7.15. The next line, however, is only mentioning, oops, let's highlight it instead. There we go. The next line is only mentioning Ibrahim and Matilda. So I'm going to do a separate one for these two. We've got 7 and 15. And it's saying that Ibrahim has 24 more stickers. Now, if I look at the ratio, I can see he's got more stickers. I can actually see he's got 8 more in the ratio. But obviously in the question, it's 24. So I'm going to pop that in a kind of separate column that I've labeled more so that I can see the numbers and make sense of them easily. How do I get from 8 to 24? I simply times by 3. So if I times by 3, that's going to give me 21 here and 45 here, which I'm now going to transfer over to the original ratio that I wrote. So we've got 45.21. We can work out Rosie's because she will also be timesing by 3, which will give us 12. We've got to work out how many more stickers Ibrahim has compared to Rosie. So the next bit of maths just uses these two values here, and I just want to work out the difference. So it's 45, take away 12. 5 take 2 is 3, 4 take 1 is 3. So the answer is 33 on the dotted line. Okay, question 12. We've got some key words happening here, haven't we? There's mass, there's volume, there's density. Those words should be triggering a formula triangle where the M is on top, and then you've got your D and your V in any order on the bottom. Okay, I always remember these is mum and dad, and mum's on top. So I'm being told I have a mass of 27. So my M is 27. I have a volume of 10. So my volume is 10 and my density is what I'm trying to work out. So density is going to be equal to 27 divided by 10, which is 2.7. You would put that on your dotted line. The unit's already done for you. Remember, when you're dividing by 10, you're just going in one place. Okay, question 13 is an estimate question. There's the key word. That tells me that I need to round all my numbers to one significant figure. So 5.7 will go to 6, 8.2 will go to 8, and 0.26 will go to 0.3. Now I can tidy the top up super quick, but now I've got the problem of dividing by a decimal, which I don't want. So I'm going to times through by 10. I must do both the top and the bottom to keep it equivalent. This will give me 480 to divide by 3. So let's go into our bus shelter. 3s into 4 go 1. 3s into 18 go 6. 3s into 0 go 0. 160 goes on the dotted line. Okay, question 14. It's quite a big question. It was 3 marks, so it wasn't giving lots of marks, but it's at that high level of thinking and manipulating and problem solving. So we've got the diagram showing a prism, and we're told that the cross section's right angle. We can see that in the diagram as well. The base is 5, the length is 25, and the volume. And that's kind of our key word that's going to help us get into this problem. We've got to work out the height. So the height is here. And what do we know? We know that this is linked to the topic of volume. Now we find the volume by doing the area of the front face times by its third length. Basically, what we're saying by that is you've got a front face, and then the third length is the length that turned it from a 2D shape into a 3D shape. So for this question, this length turned it into a 3D shape. And this is our front face, which was our original 2D shape. We know the front face is a triangle. We know that triangles are base times height divided by 2. That's how we find the area. We know the base is 5. We don't have the height, but we know that it was divided by 2. Then it was times by the third length, which is obviously this one here, 25. And it gave the answer of 750. Now, all I need to do is slowly undo that problem. So 5 was multiplied to the height. It was then divided by 2 and multiplied by 25. The multiplied by 25 was the last thing that happened in the problem to produce 750. So it's going to be the first thing that I undo. So I'm going to take the times by 25, hop it over, and it's going to land as divide by 25. So again, we can use our bus shelter even, or bus stop, depends on how you describe it, to help us solve. So can't get any, carry it over. 25s into 75 are 3, and then add that 0. So it's 30. So what I've now got is 5 times the height divided by 2 equaling 30. I'm going to get rid of the divide. It will land as times by 2. So I now have 5 times h equals 60. And when I divide through, I get the height is 12. Okay, so question 15, we've got a prism again. We've been told its height is 3 and that the volume is 18. Now, if we've been given the volume, probably means that we're going to need to use it. So remember, volume is the area of the front face times by the third length. If we look at this formula in the box, there is no volume, but there is area. And area in this formula is also area in this formula. And that's where the link is in this question. We've got to work out the pressure on the floor. Sorry, we've got to work out the force. We've been told that the pressure on the floor is 75 newtons. So we know that the pressure is 75. We've got to work out the force. So that's our problem. And we're not going to be able to work that out unless we've got the area as well. So area is going to come from this piece of knowledge here. This is the area of the front face. So area of our front face times by its length that made it 3D, which is 3, is equal to 18. We're going to take the times 3. It will land as divide by 3. And the area of our front face is equal to 6. Now I can use my pressure equals force divided by area. My pressure is 75. I don't know the force, but I know the area is 6. Times through by 6, and you've got your force. So again, you might set this up, use whichever method is easiest. Just multiply and then add through the diagonals, and you've got the force is 450 on the dotted line. If you found the video and the resource useful, then please do subscribe. I'm currently working on the calculator resource that will drop hopefully in the next few days. And good luck with using this resource. Good luck with your November exams. And I hope I'm able to be a good support whilst you're studying and preparing.